This is the Reasonable Faith Podcast with Dr. William Lane Craig. I'm Kevin Harris. Bill, it must be providential because I happened to pick up this magazine in the airport and you happened to pick it up at your ophthalmologist office, and we've both read the same article, so let's discuss it. It's in Scientific American, Questions about the Multiverse. What lies beyond the cosmic horizon of 42 billion light years? Now, that's the cover of Scientific American. What do you think about the cover?
Well, I think it's very interesting because the cover suggests that the multiverse is something that actually exists, and we can have questions about it, sort of like questions about the Jurassic period or questions about Venus or something of that sort. But in fact, when you read the article, which is by the prominent cosmologist George Ellis, the main question about the multiverse is there any such thing at all? And Ellis gives a number of reasons for his skepticism that there is such a thing as a multiverse. So when it talks about what lies beyond the cosmic horizon of 42 billion light years, that is a question that's only about what Ellis calls the level 1 multiverse, which would just be a universe which is spatially a lot bigger than what we can see. And that's really quite trivial. That's not the sort of multiverse that has captured the popular imagination or the imagination of cosmologists who would appeal to the multiverse as a way of explaining away fine-tuning. They're talking about what Ellis calls a level 2 multiverse, which is an ensemble of disconnected, unrelated, inaccessible parallel universes invested with all sorts of speculative properties.
Exotic universes, as I've heard it referred to. Well, the cover and the article aren't exactly toe-to-toe. It would lead you to believe, like you said, that the multiverse is kind of a given, and here are the questions. When actually, the article is quite skeptical about most versions that are being speculated on today.
That's quite right, and I think that this betrays a pattern that Scientific American has followed over the last several years of promoting articles that seem to be based upon speculations and conjectures about the origin of the universe, which have a decidedly anti-religious tone to them, like the myth of the Big Bang and so forth. They have often explicitly put the Pope's statement that the Big Bang theory supports the doctrine of creation up as something that has now been disproven and a sort of foil against which to react. And yet when you read the articles, they turn out to be about conjectural, speculative hypotheses for which there's no empirical evidence whatsoever. But there seems to be this determined effort to promote among the popular reader the impression that, in fact, the universe is eternal in the past, that the doctrine of creation has been undermined by recent scientific advances, and in this case, that the idea of design is undermined by a multiverse. Fortunately, Ellis is a very sane and conservative cosmologist who writes quite opposite to the sort of cover that the editors chose to put on the magazine.
Tell us more about George F.R. Ellis.
George Ellis was once described to me by Tony Rothman, who is himself a cosmologist, as the man who knows more about cosmology than any other single living person. That is how eminent he is in his field. He's South African at the University of Cape Town, and I first met him when Jan and I were in South Africa. I was invited by an astronomer, David Block, to speak at an astronomy conference in Johannesburg on galaxy morphology. It was on the formation of galaxies. And during the day, they had the papers presented by the astronomers who were in attendance. And then in the evening, they would have scholars from other fields present papers on related topics. So, for example, one evening there was an artist who spoke on visions of the universe in her art and so forth. And I spoke from a standpoint of a philosopher on the ultimate question of origins. And I was surprised to discover that my commentator that evening assigned to respond to my paper was none other than George F.R. Ellis. And I thought, wow, what is he going to say? Well, after my presentation, Ellis got up and he said, that is one of the finest presentations of the evidence for the beginning and origin of the universe that I've ever heard. And he said, I want to further explain some further facts. And he then went to add additional information, including he began to talk about moral facts, moral values and duties, and how these point beyond the universe to its ground in some sort of a transcendent source of value.
Wow.
So it was quite remarkable. I thought, here's the philosopher talking about cosmology and the cosmologist talking about metaethics and philosophy. So that was my first acquaintance with George Ellis personally, and I've continued to read and profit from his scientific work over the years.
Scientific American synopsizes this entire article by saying, in brief, the notion of parallel universes leapt out of the pages of fiction into science journals in the 1990s. Many scientists claim that mega millions of other universes, each with its own laws of physics, lie out there beyond our visual horizon. They are collectively known as the multiverse. The trouble is that no possible astronomical observations can ever see those other universes. The arguments are indirect at best, and even if the multiverse exists, it leaves the deep mysteries of nature unexplained. Now, George Ellis does make a case that no matter how far the technology advances, there are going to be regions in the universe that we're not going to be able to see or reach. And especially if some of these level 2 multiverses exist, they're way out of any range.
Well, what's important to understand about what he calls level 2 universes is that they are not spatially contiguous with this universe. It's, as it were, a different dimension. It is totally divorced from this universe. The level 1 multiverse is really a misnomer. I don't like that name. All that means is just that the universe is a lot bigger than what our farthest instruments reach. That say our farthest telescopes reach out to X billion light years. There may well be stuff beyond that. That would hardly be surprising. So that level 1 multiverse isn't that interesting. All of those regions, they're really regions, belong to this universe, share a common origin, and are governed by the same laws of nature. The speculative hypothesis concerns these, what he calls level 2 multiverses, and that's the real multiverse, where you have a world ensemble of unconnected universes comprising a sort of world ensemble of universes, of which ours is but a part. And as I say, these are not contiguous with each other in any way. They're not next to each other. It's like different space-times, if you will. Here is our space-time, and these other things would represent different space-times. So that's why I think Ellis is extremely cautious about these, because it's really a very metaphysical hypothesis.
He says so himself, as we'll get to his quote here in just a moment. By the way, he says we can see about 42 billion light years out. How in the world do we get out that far? Isn't that amazing?
It is astonishing, isn't it?
He says that there are 7 arguments that come into play some way or another when examining the issues of multiverses. And one would be that space has no end. Mm-hmm. Space goes on forever, that there is no wall that you're going to run into, or there's no end of space. Mm-hmm. He says that he doesn't necessarily believe that. What do philosophers speculate on?
The idea here is that space might be curved, Kevin, so that three-dimensional space would be the analogy of the two-dimensional surface of a sphere. Think about the surface of the Earth. The surface of the Earth is finite, right? That is not an infinite space. That's a finite amount of space. But there isn't any edge to the surface of the Earth. It's not like if you go in a certain direction, you come to the end and fall off. You just come back to where you started. Well, similarly, we don't know if space is curved or not in such a way that it may well be finite. It might not be infinite at all. So this would be the discussion of the level 1 multiverse. Is space infinite? Does it go out like a Euclidean plane? Remember in high school geometry, you studied the flat Euclidean plane, which just is infinite in both directions. Is space like that, except three-dimensional? Or could space be like the surface of a sphere, finite, but without a boundary or edge? There's no way to tell.
And he says that if you assume space goes on forever, that makes it easier for you to imagine the different things involved in this world ensemble. I mean, if space goes on forever, he says, it's then easy to imagine more elaborate types of variation, including alternate physics and things like that, and universes where there are physics that are totally unlike ours.
Well, that would be a violation of the Copernican principle, which governs all of modern cosmology and astronomy. The Copernican principle, based on Copernicus obviously, says that we occupy no special place in the cosmos. There's nothing about our place in the cosmos that is atypical. And it's only on that basis that we can assume that the distant objects we see in the universe do obey the same laws of nature that we observe here on Earth. This is the foundation of modern astronomy and cosmology. So it would be quite gratuitous to think that these other regions of the universe have different laws of nature. Indeed, that would violate the Copernican principle. So this level 1 multiverse, which is just a big universe, is all a spatially big universe, doesn't really give any grounds for varying the constants and quantities that make up the stuff of fine-tuning, which is the principal motivation for these multiverse hypotheses.
Yes, and we're going to get to that. That's a biggie. He says another claim is that known physics predicts other domains. He has trouble with this one as well, that physicists have not substantiated that the dynamics of these fields would cause different laws of physics to operate in different bubble universes.
Now here he seems to have moved to the level 2 multiverse, talking about these different space-times. And what he's suggesting there is that even if there are these different so-called bubble universes, and we're just like one bubble in this sea of bubbles that represent other universes, he's quite rightly pointing out that it is gratuitous, that is to say unjustified, to assume that these other universes have different constants and quantities, much less different laws by which they operate, and that these vary randomly. You've got to build in some special conditions of the multiverse which generates these bubble universes in order to get all these randomly ordered worlds, and that is quite gratuitous. He's showing the sort of ad hoc or contrived nature of some of these multiverse hypotheses.
Another argument that comes up in this area, Bill, is that the theory that predicts an infinity of universes passes key observational tests. Let me read from him. The cosmic microwave background radiation reveals what the universe looked like at the end of its hot early expansion era. Patterns in it suggest that our universe really did undergo a period of inflation. But not all types of inflation go on forever and create an infinite number of bubble universes. Observations do not single out the required type of inflation from other types. Some cosmologists, such as Steinhardt, even argue that eternal inflation would have led to different patterns in the background radiation than what we see. Land and others disagree. So who is right? It all depends on what you assume about the physics of the inflationary field.
There you go. He's talking now about what are the properties of the mechanisms that generate these inflationary bubbles. And as he says, it's quite conjectural and ad hoc, and there isn't any empirical grounds for thinking that these fields, the fields that govern or cause inflation, are in fact regulated or determined in such a way as to produce an infinity of bubbles, particularly ones that have different constants and quantities.
Very controversial at the least. He says there are physicists and cosmologists on both sides that don't see things that would lend to eternal universes in the patterns found in the background energy.
Right, and there have been claims, I'm glad you highlighted that for example, by Roger Penrose, that certain patterns in the microwave background radiation would suggest the existence of other universes. And as Ellis points out here, the jury's out on this. Not all cosmologists see these patterns the same way or interpret them or explain them the same way.
Now, this really gets to the crux, and also, I think, brings up one of the biggest issues of the multiverses, Bill, and that is fundamental constants are finely tuned for life. And Ellis believes this.
Yes.
He says, quoting here, "A remarkable fact about our universe is that physical constants have just the right values needed to allow for complex structures, including living things." Steven Weinberg, Martin Rees, Leonard Susskind, and others contend that an exotic multiverse provides a tidy explanation for this apparent coincidence. If all possible values occur in a large enough collection of universes, then viable ones for life will surely be found somewhere.
That is the main motivation, Kevin, today for the multiverse hypothesis. It is an attempt to explain the incredible fine-tuning of the universe for intelligent, living, embodied organisms like ourselves without recurring to an intelligent designer of the cosmos. And so we're both talking metaphysics here. Each side is appealing to its metaphysical hypothesis to offer an explanation for the fine-tuning. And I hadn't noticed before the words "a tidy explanation." That's actually a technical term coined by the philosopher John Leslie in his book Universes, where a tidy explanation is one that, in explaining a phenomenon, reveals that there is, in fact, something there to be explained. For example, why is it that the silk merchant selling you this drape of silk that he is holding just happens to be holding his thumb over the moth hole in the silk? Well, the fact that he's trying to cheat you is a tidy explanation of that. It's equally improbable anywhere on the cloth that his thumb might be held, right? Every place is just as equally improbable as the place where the hole is. But the fact that his thumb is over the hole is tidily explained by the hypothesis that he's trying to cheat you. That shows that there is an explanation of why the thumb is there, but also that there is something to be explained. There's something special about that place, not characteristic of the rest of the cloth. And in the same way, Leslie says, the hypothesis of a designer of the cosmos gives a tidy explanation of the fine-tuning of the cosmos, because it shows not only, it explains not only the existence of the fine-tuning, but in so doing suggests that there is something here that really needs to be explained, namely the incredible coincidence that all of these values are in this extraordinarily narrow range appropriate for intelligent living organisms.
Ellis says that arguably, quoting now, these exotic universes are the only scientifically based option we have right now, but we have no hope of testing it observationally. So he says strictly, apart from metaphysics, apart from God, and so on, this is kind of the best thing going right now if you want to explain this remarkable fine-tuning.
Yeah, and for a scientist who's committed to methodological naturalism, Kevin, that is
like
to
Steven
say,
Weinberg.
Yes, yes, indeed. For the scientist who says that science can only allow naturalistic explanations into the pool of live options, the option of an intelligent designer of the cosmos isn't even permitted into the debate. It's not even permitted in the pool of live options. And so it would just be excluded methodologically. And then you're left with the multiverse hypothesis. That's all you've got. But unfortunately, as Ellis says, it's empirically untestable.
That would require a degree of faith, and that's a big no-no. Oh, wow. His next issue is fundamental constants match multiverse predictions. Now, this is very technical here. Bill, maybe you can synopsize what he's talking about.
What he draws into question here is the theory of probability that multiverse proponents are implicitly assuming in order to say that it is improbable that the constants in quantity should have the values that they do, and particularly the values lying right on the edge of the life-permitting zone. And Ellis wants to question that based upon the lack of a measure of probability for this. And I think that the more fundamental objection here, frankly, Kevin, is that what this improbability shows is not that a multiverse exists. What it shows is that the values of the constants and quantities cannot be explained simply by chance alone without recurring to a multiverse or else to a cosmic designer. The improbability of the fine-tuning is evidence equally for either a multiverse or for a cosmic designer. But in and of itself, it provides no evidence whatsoever for preferring the multiverse hypothesis over the designer hypothesis.
The next argument that comes up in the multiverse issue is string theory. It's been said that string theory predicts a diversity of universes. Ellis says here, string theory has moved from being a theory that explains everything to a theory where almost anything is possible. In its current form, it predicts that many essential properties of our universe are pure happenstance. If the universe is one of a kind, those properties seem inexplicable. How can we understand, for example, the fact that physics has precisely those highly constrained properties that allow life to exist? If the universe is one of many, those properties make perfect sense. Nothing singled them out. They are simply the ones that arose in our region of space. Had we lived elsewhere, we would have observed different properties, if we could indeed exist there. If life would be impossible in most places, he says, quoting there. He goes on to say, but string theory is not a tried and tested theory. It is not even a complete theory. If we had proof that string theory is correct, its theoretical predictions could be a legitimate, experimentally based argument for a multiverse. We do not have such proof.
So he calls into question string theory, indeed, that it is even a theory. It's really a conjecture.
And what it's become
yes.
this...
And even more fundamentally, though, even if the theory is true, it doesn't do anything to explain why our universe has the constants and quantities that it does, because it permits this cosmic landscape of around 10 to the 500th power, different possible universes. And so it doesn't do anything to render physically necessary the particular constants and quantities that we observe. So you've got to conjoin your string theory with some kind of multiverse hypothesis in order to generate the many worlds in the landscape. But that then is assuming already that the multiverse exists. It's not a proof for the multiverse. It's based on the assumption that there is one.
String theory, he seems to be saying, has become this big metaphysical thing that has become mysterious and metaphysical, and it can explain anything and everything. Why was the kitchen so dirty? Well, it was string theory.
Well, initially the hope was that it would explain the specific values of the fundamental forces of nature that we observe, and then it was discovered that far from doing that, it permits this vast landscape of different possible worlds governed by different values of the forces and constants of nature.
My son, who's 16, is really intrigued by this one, Bill. All that can happen, happens. Ellis says, in seeking to explain why nature obeys certain laws and not others, some physicists and philosophers have speculated that nature never made any such choice. All conceivable laws apply somewhere. The idea is inspired in part by quantum mechanics, which, as Murray Gell-Mann memorably put it, it holds that everything not forbidden is compulsory. Particle takes all the paths it can, and what we see is the weighted average of all those probabilities. Perhaps the same is true of the entire universe, implying a multiverse. But astronomers have not the slightest chance of observing this multiplicity of possibilities. Indeed, we cannot even know what the possibilities are.
He's calling into question there, again, the lack of empirical evidence for these suggestions that it's not doing science. I would question even more fundamentally, though, this, what I would regard as patently ridiculous claim that because something is possible, therefore it's actual, that anything that's not impossible is real. That, to me, is just patent. Yeah, it's compulsory. That's just patently obvious. That is to collapse all modal distinctions between possibility and actuality. And it's so obviously wrong. For example, it's possible that no multiverse exists. Therefore, if that's possible, then it's true. And therefore, there is no multiverse. You can prove anything if you allow these modal distinctions to collapse.
And just to review what we've talked about in podcasts past, a particle will take every conceivable path, but it doesn't actually do that. That's just a mathematical formula.
Yes, that's the sum over history's method for calculating where it's most probable for a fundamental particle that leaves point A and where it's going to strike some target screen at point B. And to interpret this realistically as a piece of metaphysics is, again, just gratuitous. It's just a calculation device for finding the most probable path of the particle.
When it gets down to layman, we think this particle does absolutely mystical, unbelievable things, and that it does contradictory things, that it takes every possible path, and not realizing that that is not what is happening, but rather just a formula, as you were saying, right? I mean, do you see how when it trickles down?
Oh, this is the way it's presented by people like Hawking and Mladenov in the grand design. They present this as a literal description of reality rather than as simply a calculational device. And I think that's just, again, a gratuitous piece of metaphysics for which there's no grounds whatsoever. It's a mathematical reckoning device or trick. It's not meant to be a serious, literal description of the way the world is.
Let me conclude, Bill, with a couple of quotes from George Ellis in this article. Proponents of the multiverse make one final argument, that there are no good alternatives. As distasteful as scientists might find the proliferation of parallel worlds, it is the best explanation. We would be driven to accept it. Conversely, if we were to give up the multiverse, we need a viable alternative. This exploration of alternatives depends on what kind of explanation we are prepared to accept. Physicists' hope has always been that the laws of nature are inevitable, that things are the way they are because there is no other way they might have been. But we have not been able to show this is true. Other options exist too. The universe might be pure happenstance. It just turned out that way. Or things might be, in some sense, meant to be the way they are. Purpose or intent somehow underlies existence. Science cannot determine which is the case because these are metaphysical issues.
Yeah, there you go. See here, the camel's nose of naturalistic heresy has poked under the tent. He's talking now about purpose, intent. Those are code words, as it were, for intelligent agency. And that is an equally valid explanation of the fine-tuning of the universe, that this is a product of design.
His final quote here is, "Parallel universes may or may not exist. The case is unproved. We are going to have to live with that uncertainty. Nothing is wrong with scientifically based philosophical speculation, which is what multiverse proposals are, but we should name it for what it is."
Oh, you got to love it, Kevin. Scientifically based philosophical speculation. And I think in that sphere or in that arena, the theist needs to have a place at the table as well. One thing missing from this article, Kevin, that George Ellis did not discuss is that there are very substantive arguments against the existence of a multiverse. And physicists such as Roger Penrose have pressed these very forcefully. In my own work, I have shared some of these arguments to the effect that if a multiverse did exist, we ought to be having very different observations than the kind of universe that we do observe. And this gives quite good grounds for thinking that a multiverse does not exist. So on naturalism, at least, I'm persuaded that the indirect evidence is that there is no multiverse. If there is a multiverse out there, I think it would only be because God has created it.